this. And I'm still sort of playing around with the audio here, so I'm not sure how the audio is going to come through. But I'll put a playlist, a YouTube playlist on the website where you can go and you can find all the lectures from this class. Is that clear? Like I'll record what's on the screen, and I'm going to try to record the audio as well as I can. All right? But it might take a little while before you get that played and get it right. I'll let y'all know more about that later. All right. When we consider the rounds of physics, there's a table in your book. Depending upon the size or the speed of what we're studying, we sort of have different rounds that we consider. So let's take the size and the speed. So on this graph, I'll have the size over here, and it'll go from really big to large to small. Like really big being the universe and galaxies, large being like me, because I'm a pretty big guy, and then small being like submicroscopic, the quantum levels. And then on this axis, we're going to have speed, and we'll go from slow to really fast. All right, really fast meaning greater than about 1% the speed of light. And 1% the speed of light is still super fast. All right, and then we're going to call these the really big, or rather the large and the slow. We'll call this classical physics. That means how I move around and how forces act on me. That's going to be classical physics. The really small and slow, we'll call that quantum physics. We won't get so much into it, but talking about how electrons and protons and other submicroscopic particles react. In the small and fast, that's going to be relativistic. Or excuse me, the large and fast will be relativity. In the small and fast, that is microscopic particles moving very fast, that's going to be relativistic quantum physics. And then this really big, I think this is sort of a new area, so we don't really have a word to describe those things. That is, how does physics act on the scale of the universe and of the galaxy? So what we're going to study in this class is this classical realm, largely. So you'll be responsible to know what these other things are called. That small and slow, looking at atoms, that's called quantum physics. Fast and sort of normal size or large, relativity, and then relativistic quantum physics, looking at particles that are small yet move very fast. All right. We're going to be dealing with a number of physical things, and so we need to know the units. Scientists use units to make measurements when they do these experiments, and you do as well. I mean, everybody uses units. Units. We adopt standards. Of measure for physical properties. That is, if we want to measure the length or the mass or something, we'll have three basic units. Do I know what the three basic units are, or what are they measurements of? If we wanted to describe something physically, what would we need to know? What would one thing be? Okay, yeah, weight of mass. We're going to talk mass. So we'll need a unit for mass. Okay, velocity is going to be made up of a couple of different units. I need a more fundamental unit. Size, basic size. So how would we describe that? Like that. Okay, length, yeah. Our height would be appropriate too. I'm going to write length. So we have three basic units: length, mass. With length and mass, we can describe the physical properties. So what do we need another one? Right, we also need time. So these are the three basic quantities, our standards of measure: length, mass, and time. And we'll need to, we have a fourth basic quantity, and we'll get to this later. Don't worry about it right now. But that fourth basic quantity is going to be called charge, and we'll use that towards the end of the semester to talk about charge particles, electrons, protons. All right, so we have three basic units: length, mass, and time. Don't worry about charge right now, but that's going to come down the road. Length, mass, and time. Now, we adopt systems to describe each of these. There are a number of different systems, but we have two primary systems that describe these. We have the British system. That's what we use here in the United States. And you'll use it some in your work, but also you use the other system. Anybody know what the other system is called? The metric system. Yes, so we have the British and the metric system. While it's called the British system, do you know what the British use? Right, they use the metric system. I think we're probably the only country that uses the British system. The British system has units for each of these. For length, the British system is feet. Right, like I'm 6 foot tall. Does anybody know what the unit for mass in the British system is? Huh? No, not stones, not pounds either. Listen, you're going to impress your friends if you know. No, no? No, no. Those are all moments of weight. And those are related to mass, but they're not the same thing as mass. All right, the British system, the unit for mass is the slug. Isn't that cool? The slug. Okay, I think it's kind of cool. All right, so we have feet, slugs is the unit for mass, and then what's the unit for time? Seconds. All right, in the metric system, which we're going to use primarily, we also have units for these. Well, we'll come to this in just a second. All right. Within the metric system, you have two separate systems. You have the SI system, which means System International. It's French, so I might be spelling this incorrectly. I'm going to put an E on the end. It's the International System of Measurements, the SI system. This is also called the MKS system. And then apart from that, a separate system within the metric system is the CGS system. The SI or the MKS, and then the CGS. Now just a hint, the M, the K, and the S are the first letters for the units for length, mass, and time. And then likewise, CGS are the first letters for the units for mass, length, mass, and time. So what do you think the M stands for? Meters. And then the K? Not grams. The K, right? Kilograms. Yes, so K. And then S, of course, is seconds. And what about CGS? Centimeters, grams, and seconds. So within the metric system, you have this MKS system and the CGS system. So MKS is meters, kilograms, and seconds. And then CGS is centimeters, grams, and seconds. Sometimes in certain fields, you'll use units that are in neither of those systems. Like for example, if you're measuring blood pressure, what do you use? You use either centimeters or meters. What do you use to measure blood pressure? What's the unit of measurement you use? Millimeters, right? Millimeters of mercury. And that's because it's just a more appropriate unit. his class, we use the MKS, meters, kilograms, and seconds, which is this system, using meters, kilograms, and seconds. I think that that's probably a pretty good place to stop.